Hello, this is Scott Loisel. Welcome to my proposal presentation for N516. This presentation will present the details of and rationale for a project that I'm calling Exploring Analog Synthesis. The first section of this presentation will set the stage, describing the user interfaces of synthesizers, how they evolved, and the effects that evolution has had on musicians trying to learn the technology. The next step of the presentation will be about the project, its purpose, the issues it's intended to help solve, and the project goals, along with how those goals will be achieved. The final section will get into the technical details of the project, which is in two parts: a website to act as a container, and an interactive application that will be incorporated into it. Synthesizer interfaces were originally quite simple. It's interesting that a lot of folks find the look of an old modular synth to be very complicated because the truth is, it's actually the opposite. It's actually the most simple. Because every function is immediately apparent when you look at it, and those functions never change. This type of interface design was widespread amongst virtually all vintage synths, which meant that once you learned what a given control did, you didn't have to relearn it, because its function never changed. A filter frequency was always a filter frequency. This made it comparatively simple to learn the building blocks of a synth from the ground up. It also meant that if you were a synthesizer player in, say, the mid-1970s, you were, by default, a synth programmer, because these units had no preset memory locations. So if you were playing one of these and you wanted to have a different sound, you had to know how to turn the knobs. It wasn't something that people thought was scary. But then, microprocessor-controlled preset memory locations appeared. These allowed a user to set all of the controls of the synthesizer for a certain sound and essentially take a snapshot of it, and then change it all at the push of a single button. While this was wonderful in one way, it led to user interface designs that, by the 1980s and 90s, often provided as little as a single control with which to adjust an astounding range of parameters. Now that is scary. Someone trying to learn synthesis on a unit like this could easily feel overwhelmed, and people often abandon the idea of learning to make their own sounds. This brings us to the present-day scenario, where many younger players have never had a chance to interact with a synth that had a user interface designed to be easy to understand, and many of them stay stuck on factory presets because they simply don't know where to start. The purpose of this project is to address some of the issues surrounding the effect that complex user interfaces have had on the development of musicians. It's conventional wisdom that musicians generally want their music to have some originality. What isn't talked about as much is that many musicians are unknowingly using a number of the same identical sound presets as any other musician with the same make and model of synthesizer. So the goal of the project is to encourage and inspire musicians to explore the creation of their own sounds, helping them to express their originality not just in their choice of notes, but in the creation of the sounds with which they choose to play those notes. With the complexity of interfaces being a problem, the project will seek to achieve its goal by keeping things simple. Instead of aiming to achieve expertise for the user, the technical objective will be to focus only on a narrowly defined set of rudimentary concepts, most concisely expressed as signal flow. The idea being to help the user develop enough confidence to continue their explorations outside of the EAS application. The design and layout of the project will be in the form of a website encompassing 3 global sections. The first section will be an About section, or an informational section, designed to provide an orientation for a user as to what the application is, how it fits into the website, how things work, what the goals are, and how they'll be achieved. The second global section will contain a series of multimedia demonstrations illustrating the concepts of analog synthesis. These demonstrations will tie in with the third tutorial section, which will be the actual EAS interactive application. The rationale for creating the project in the form of a website is that it allows individual elements to be easily added or amended. Likewise, the interactive application can be refined even after the site is up, allowing refinements to be made based upon ongoing evaluations, with the amended application simply uploaded when it's ready. This avoids the complexity involved with amending and updating an application that's designed to be downloaded onto a user's machine. The first main link will open a new page containing content to get a user started. It will answer specific questions by offering a user two different ways of accessing the answers: a static version with text only, and a dynamic version that presents the same information but with audio and video and some animation. This is to allow users without the patience to sit through the pacing of a preset video to read it as text, where they can go at their own speed, or the opposite. There will also be links to take users directly to either the demo section or the tutorial section, or back to the home page. The demo and interactive sections will contain matching content, just delivered differently. In other words, for each specific topic covered, there will be a multimedia demonstration of it in the demo section, and then a matching version of that same topic covered in the tutorial section. For instance, the first topic will explain how a keyboard controller sends control voltages and gate signals. If you look at this topic in the demo section, you will see a video with narration, which can be disabled, still text, and graphics that illustrate this. If you look at this section in the tutorial, it will contain the same graphic of the keyboard, but no narration. And the keys will be hot, they'll be interactive, so if a user clicks on a key, a display will show the control voltage output, the note it would trigger, and the gate signal state. In addition to explaining what control voltages and gate signals are, topics covered will include the difference between audio signals and control signals, voltage-controlled oscillators, voltage-controlled attenuators, voltage-controlled filters, the envelope generator, the 1 volt per octave protocol, and how that tells oscillators which note or pitch to play. This part will actually be the first topic that is covered in the tutorial as well as in the demonstration. Then, adding a voltage-controlled attenuator, or VCA, to enable manual control of the volume. Then adding an envelope generator to control the VCA to enable changing the volume over time. Then adding a voltage-controlled filter to enable manual control of the timbre. Then adding an envelope generator to control the filter frequency of the VCF to enable changing the timbre over time. Then using the output of an oscillator in the sub-audio range as a control signal instead of an envelope generator. Then using an LFO to control the output of a VCA. And then using that LFO signal to control the filter frequency of the VCF. What all of this is designed to impart to the user is a sense of how straightforward and simple the basics of analog synthesis really are. And in the same way that a pianist learning how to play a C scale in one octave can then simply move their hand and play that exact same scale in another octave, leveraging the information, a user who learns these simple concepts will then automatically understand as additional modules of the same type are added, and this knowledge base will function as a foundation upon which they can learn additional and more advanced concepts that aren't covered in the Exploring Analog Synthesis application. Thank you for watching my presentation. I hope you enjoyed it.